today, 2C, we're doing polynomial equality, and we have done this in Year 11 methods, but again, we're going to make it a little bit more complex. So we will start with some stuff that we're familiar with. Firstly, if we have x plus 3 is a factor of this cubic, okay? I know it's a cubic because the leading power is at 3. All right, and so then we know if we have a linear factor times a quadratic, that's going to give us a cubic. Now, in the past, when we've set up a problem like this, I've said we take the linear factor and we multiply it by the general quadratic, a squared plus b plus c, and we determine the values of a, b, and c that way. That is a foolproof process, right? But because we're sort of getting to year 12, we can make some, we can see already some of the values of a and c, and b just needs a little bit more solving, okay? So my reasoning is a has to be 1 because x times x squared gives me 1 lot of x to the power of 3. Okay, so I think we can see that pretty clearly. And then the last term at the end is 36. So that means 3, or here, 3 times c has to be 36. So c has to be 12. All right, so already we've identified what 2 of them are, and so there's a lot less involved in determining the value of b. So we will, in a moment, what I'm going to do is I'm going to perform the full expansion. It is unnecessary. All you are asked to do is determine the other roots, okay? And so we know minus 3 is one of the roots from this factor, but to determine the other roots we need the value of b, and then we can factorize that quadratic. So let's go ahead and determine the value of b. I'm going to perform the full expansion. This is a necessary step in solving the problem. If you can see what the value of b is a little bit bigger. Okay, so let's go through. We're just going to FOIL it. We're going to have x to the power of 3 plus bx squared plus 12x. All right, then we're going to have plus 3x squared plus 3bx, and then plus 36. All right, so if we're going to collect them together, we have 2 procedures for solving b. We can take this one and equate it with the 9, okay, the coefficient of x, or we can take this one, b plus 3, and equate it with the coefficient of x squared. All right, so let's do that. B plus 3 equals minus 4. B plus 3 times x squared is equal to the minus 4 lots of x squared. So therefore b is minus 7. All right. So this quadratic that we have here then, the quadratic factor, or we can write the whole cubic out, x plus 3 times x squared take 7x plus 12. And so we need to factorize this quadratic factor. Okay, so we could put it in our calculator, we could graph it and g-solve the roots. Let's use the cross method. All right, so we can see we've got 2 numbers, x and x, and 2 numbers that multiply to give us positive 12, and when we add them together we get minus 7. So that's going to be minus 4 and minus 3. Minus 4 times minus 3 is positive 12, and minus 4 plus minus 3 is minus 7. Alright, so that means that the factors, as all linear factors, x plus 3 times x take 4 times x take 3. So this cubic and this cubic are the same. Here we've expressed them in different forms, and they're both useful, right? Okay, this is particularly useful because it tells you the y-intercept. All right, this is particularly useful because it tells you the roots. Okay, what are the roots? Therefore, the roots are minus 3, 4, and positive 3. All right, put minus 3 there. That factor will be 0. Put positive 4 there. That factor will be 0. Makes the whole thing equal to 0. And then the same with positive 3. Okay, excellent. Let's move on to the second one, unless there's any questions about that. No. Okay, so be a bit more smarter about it than we were in year 11. All right, we don't need to write out the whole thing. We can often identify this value of a and even c straight away. Okay, so here we're told this quartic, okay, a melted quartic because the leading power is 4, equal to the product of these two quadratic factors. Alright? So what we'll do is we're going to expand these and then try and determine the values of a and b in that manner. So let's go through and perform this expansion. We're going to have x to the 4 plus bx to the 3 take 2x squared. Alright, so I've just multiplied the x squared term through. Now let's multiply ax through. We're going to have plus ax to the 3 plus abx squared, and then take 2ax. And then lastly, we will multiply the plus 2 term through, plus 2x squared, plus 2bx, and then take 4. Let's collect those. Okay, so if we look at this quotient that it's equal to, right, we can start equating the terms. We've got a times b, if we look at the x squared term, a times b is minus 4, alright, that's not particularly helpful. We've got b plus a. b plus a is equal to 0 because there is no x to the 3 term. Alright, so what we've got in here, if we're going to write this polynomial in order, we've got x to the 4 plus 0 lots of x to the 3, take 4 lots of x squared. Okay, you can see my power's going down by 1. We've got no lots of x to the 3. And here we've got b plus a times x to the 3 in our expansion. So therefore, b plus a has to equal 0, which means b equals minus a. Alright, so we've got b and a are equal to one another in magnitude, but one is positive, one is negative. The other piece of information we have is this one here, that a times b is equal to the coefficient of x squared. So a times b, and the coefficient of x squared is minus 4. A times b is minus 4. We've got to combine these two. Let's use this one. We have b equals minus a. So where I've got b up here, I'm going to substitute it for minus a. I have a times minus a. Alright, b is minus a, so I plug that there. Equals minus 4. So yeah, we have minus a squared is minus 4. A squared is 4. And so we'll go a is 2. Alright. If a is 2, then b is minus 2. Yes, okay, so if you want to do that, if a is plus or minus 2, alright, it has to be one or the other, because if a is plus 2, b is minus 2, if a is negative 2, b is plus positive 2. And so it doesn't matter, alright, but one of them has to be negative, and so that's why I've just defined it as a positive. Good pick up, okay, so I've just been very clear. It has to be one, and this one has to be the other. Excellent. Okay, so we've found the values of a and b, but then it asks us to do something else, doesn't it? It says, find the values of a and b, and hence solve this equation. Alright, so we are going to need a bit more board space. I might come back over onto this one. Okay, so we've got to make some link between this equation, x to the 4 plus 8x, equals 4x squared plus 4. We've got to make a link between this equation and what we were just up to over here, finding the values of a and b. The clue there is that it says hence. Okay, whenever it says hence, it means using what you just did. So this is the quadratic that we had, isn't it? The quadratic that we had. And we can see some sort of similarities here. You know, if we're asked to solve something like this, my temptation straight away is to to one side, isn't it? Okay? So if we went ahead and did that, we're going to have x to the 4, take 4x squared plus 8x, take 4 equals 0. Okay, and now it's immediately apparent. This is the quartic that we started with, and one way we can express it is a product of those quadratic factors, which are x squared plus 2x plus 2, and x squared take 2x take 2. Alright, now we are asked to find the roots. Okay, we're going to find the roots of both of them, and we're going to do it using quadratic formula. Okay, I know I have to use quadratic formula because I can't use the cross method, and the way we can check if we can use the cross method or not is to use the discriminant, isn't it? Okay, so let's always have that in our mind. B squared take 4ac. So if I'm thinking about that, I'm going 2 squared, okay, that's going to be 4. Take 4 times 2 times 1. That's going to be take 8. So I've got 4 take 8. It's negative 4. It's going to be an irrational. It's going to be a. It's going to be an imaginary root, which means I cannot use the cross method to solve it. Okay? I need to use quadratic formula. So you can do that in your head, and if it helps, you can write it out. And if you can't see the problem using factorization immediately, we can check on our calculator to support us, or we can just link straight into quadratic formula. So let's do it for the first quadratic factor here. X is going to be minus b, I'll write the formula right here so you guys remember it, minus b plus or minus square root b squared take 4ac on 2a. So we're going to have minus 2 plus or minus the square root 2 squared take 4 times a times c, all on top of 2a. So let's process this. Minus 1 plus I, or minus 1 take I. Okay, that's sort of the extent of complex numbers that we need to remember. Just that square root of negative 4 can be expressed as square root of 4 times I. Okay, let's do it for the other one as well. Okay, so our second one here, it didn't have imaginary roots, but we still can't factorize it because the discriminant is not a squared number. Okay, the discriminant needs to be a squared number in order for us to be able to factorize it using the cross method, and we can see it has irrational roots after we've processed the quadratic formula anyway. Alright, so any questions about that one? Okay, so there were 2 parts to it. Find the values for A and B. We're reasonably familiar with that process. And then over here we had to make a link between this equation and the polynomial. When we bring it to one side, we can see it pretty clearly. And then we're just solving the roots. Okay, what are the roots? You put any of these 4 values into the equation, it will make it equal to 0. Alright, next one is a little bit trickier. Okay, we have a cubic polynomial. three linear factors. Two of them are identical. So the way I'm going to show you how I've set this one up to start with, and then I'm going to explain my reasoning behind it. The first thing I've done is I've written this as a linear factor, 2x take a times x take b squared. Okay, so let me explain my reasoning then. This is the identical factor. Okay, if it's an identical root, that means it touches at that point. It means it's a squared factor. All right. I have to have a 2 out the front here, because if I put the 2 in this factor, then we're going to have 4 as the leading coefficient. Okay? So we have to have the 2 here. We're going to have 2x times, this is going to be x squared, is going to give us the x to the power of 3. I don't know what this value of a is, and I don't know what this value of b is, but once I expand this and begin to equate it, we should be able to identify them. Okay, is that okay? Yep, so that's why I've set it up like that. And whenever it says one of the roots is identical, that means it's a squared factor, all right? And we want to try and remove the amount of variables from there as well. Okay, so let's perform the expansion. So I've got 2x take a. The first thing I'm going to do is perform a perfect square here. Okay, and then I will distribute it for this one out the front. So 2x to the 3, 4bx squared. Now it's just going to be a matter of equating the coefficients that we've got to solve here. So the first one we've got, 4b plus a equals 15. So as you guys are doing that expansion, did you guys get the same as me? That's what I've got written down here. Yeah, that's fine. Okay, we've got 4b plus a, or minus 4b plus a equals 15. Let's not forget that negative. So even then we might write it minus 4b take a equals positive 15. Okay, so we can see there, that's a linear equation with two variables. So we're going to have to somehow synthesize these two. The other one we have is 2b plus 2ab equals 24x. Okay, now this we can equals 24, sorry. Just equating the coefficients. That one we can divide by 2, right? Just to reduce the amount of factors we've got involved. B plus AB equals 24. 12. Okay, so let's combine these two somehow to solve for A and B. What I'm going to do, I'll swap A with 15 over here. I think that's going to be a pretty good procedure. Because then what we'll have is we'll have minus 4b take 15 equals a. Alright, minus 4b take 15 equals a. So plus a to both sides and take 15 from both sides. That gives me this equation. And now I've got a value for a that I can plug in over here. That's going to be a pretty good solution, I reckon. So let's come up here and do it. So we'll have b plus minus 4b take 15. Sorry, did you say something? No.
When you're factorizing, like when you've like expanded it out, you got 2b squared x at the end of the first one, and it's just 2b when you're putting it in there.
Oh yeah, good pick up. What should it be? What have I got written down here? I've got 2b squared here. Is that what you guys have? Yeah. So let's maintain that squared through. Yep. Okay. So we've got b plus a times b equals 12. Alright. So now let's perform this expansion, and we can see we've only got one variable, it's b, and I can see also that it's going to be a quadratic that we need to solve here. So let's get all of that on the same side. We're going to have b, take 4b squared, take 15b, take 12.
That b should be b squared, shouldn't it?
Right.
Yeah.
Is that's
Yeah.
oh, I haven't carried it yet. Okay, so 2b squared, b squared.
Yeah.
Very good. Thank you. Okay, here we go. B squared, take 4b squared. So that gives us minus 3b squared. Take 15b, take 12. Alright, we can divide through by minus 3. That's going to simplify that a fair bit. So we'll have b squared plus 5b plus 4. And then we can factorize that to identify the potential values of b. So we'll have b plus 4 times b plus 1. So we've got two values for b, okay? And so we're going to need to investigate both of those circumstances. Let's come back over here. Any questions so far? Alright, so firstly let's go, if b is minus 1. If b is minus 1, we have minus 4 to b, take 15 equals a. So we've got an equation here to solve for a. I'll write that one out here. Minus 4b, take 15 equals a. So let's put b in here and solve for a. We're going to have minus 4 times minus 1. Take 15 is a, so we'll have 4, take 15. So we'll have a is minus 11. So if b is minus 1, then we have a is 11. Okay. Alright, so there's a fair bit going on here because we've got, let's just focus on this case to begin with. So what does the question ask us? It said, find the roots and find the value of k. Alright, so if we have a is minus 11, that means we've got 2x take 11 times x plus 1 squared. That's what this cubic is, okay? And so the roots in this circumstance are going to be 2x take 11 is 0.
Mr. Royals?
Yep.
Should be 2x plus 11 because it's in the original question 2x take a and a is negative 11.
Yes. Yep. 2x, very good. Thank you. 2x plus 11 is 0. 2x is minus 11. So x is here minus 5.5. Or x is minus 1. That's the double solution. So they're the roots if b is minus 1. Alright? The other thing we need to find is the value of k. Okay? The value of k. And we can see from our expansion here, remember this is the cubic when we have it fully expanded, the value of k is equal to minus ab squared. Alright, so let's address that. K is minus ab squared. And let's just substitute in the values of a and b. We've got minus 11 times b is minus 1. Alright, so that's going to be 11 times 1. 11. Okay, so in the circumstance that b is minus 1, these are the roots, and this is our value of k. Alright, that's one of the possible circumstances that satisfies this equation. We need to explore the other. We've got or b is minus 4. So let's investigate if b is minus 4. And so the good thing is we're repeating that process, right? It's just a tiny bit different. Okay, if b is minus 4, this is the equation we're using, isn't it? Minus 4b, take 15 equals a. We'll have a is 1. b is minus 4, we can solve through to find a. We express it as the factorized cubic. We can identify the roots accordingly and the value of k from our equation here for k. Alright, so that one we did at the end, that's like one of the last questions in this exercise. Okay, so it is reasonably hard. Maybe not reasonably hard, there's just lots involved. I think it's a big, long process, isn't it? So let's see how we go with this exercise. That's 2b.